So welcome back to the OSDC course for Perl programmers again. And as we discussed, sorry, I have to drink it. As we discussed just before the video, we're going to take a look at one of the Perl modules, trying to write maybe a test or configure continuous integration, or at least run it locally. And in the meantime, we are going to look at Docker and how to use Docker. Okay, so that's sort of the focus of this meeting today. So let me share the screen and just remind me every time if I forget that you don't see part of the screen. Right, I think I have to resize it. So do you see the beginning, the left-hand side of the screen now?
Yep.
Okay.
Yep.
So so actually I have the list. I'll try to look at the modules that you listed in the packages, or yeah, I asked you to list projects in your JSON file in our repository, and I still haven't written the part that will display these on the website.
Okay.
So I'll still have to just look at the source code of it. But I looked at the files that you shared, and particularly I think this sounds like something simple, relatively. So something that doesn't need anything extra. The others, so this will probably need a Postgres database to run. So we'll hold it for a little bit later, because that might be more complex. It's not just code, it also needs a database, probably. Web service, that seems even more complex, because now it probably needs an external service, and then we might need some keys for that in order to use that. Apache also sounds, I'm not sure actually if this needs Apache or not. And this class is probably also needs a database in order to run the tests. Okay, maybe it can run with SQLite, but it might need more tests. So let's try to take a look at. I haven't looked at this one, so I'm not really sure. Let's try to look at this one and see if this is really. I looked at the other ones actually earlier. So okay, this is the project. Okay, and what I see here is that. It's using this Zilla. It has the Travis YAML configuration file. So in case you don't know, Travis is a continuous integration service that used to be free for open source projects, and it's paid for corporations. And the free for open source project was shut down, I think, a year ago or so. But many projects still have this configuration file, and they haven't switched to any other CI system. And we played around with GitHub Actions. So one of the things that we can try to do for this project is also to set up the CI for it. But before we do that, we would like to use we would like to test it locally, run the test locally. And for that, we're going to use a Docker file. And you can also see that it's using this Zilla. So that can be a little bit problematic because it takes a long time to install all the requirements. So let's see what can we do here. I copy the URL and go to my command line. Here I have this window where I git clone. I have this folder called OS where I put all these open source projects that I may try to contribute to them. So they are all in one place, and I can find them. So at this point, I mean, I have Perl and a lot of things installed on my computer, so I could try to do whatever it needs to be done. But I'd rather use my Docker image. So right now, I'll run the dr command here, and I explain to you in a bit what does it do. So now it opened a Docker image. Okay, it's just a command I have. Okay, I'll show you later exactly. So now we are inside a Docker container, and if I run ls-l, then I'll see the same content because the folder that I had outside is mapped inside. Okay, so now I'm running inside the Docker container. As you can see, the prompt is totally different. I'm also user root here, but I have access to all the file system from this folder and below, but not above. So that's one of the reasons I like to use Docker for these random open source projects, because it has it will separate all the it will limit the access of whatever I run here. So if there is some malicious code, then it can write to this folder, but nothing else, nowhere else. Okay. And just to remind you, if any question, just start asking.
I got a quick question.
Yeah.
Your root in this thing, is that how you normally operate?
Yes. Yes.
Okay.
Yes. I don't. Yeah.
I just think that kind of changes things a little bit, running as root.
Yeah. Yeah. I mean, it gives you more power, sort of, but.
Well, it can covers up sins, doesn't it? When permissions aren't correct and things. Anyway, okay, carry on.
Yes, probably, but you are root only inside. So this
Sure.
So you can only access whatever in this image. And actually, the way I have this dr command set up is that once I close this image, everything is gone. Well, except of whatever I save on the file system. So I'll open a separate terminal here. And actually, what happens is if I touch here a file, ABC, let's say, okay, so now it created a file called ABC, and I can see it outside, and it's owned by root as well. Okay, so that's not. So I have to be a little bit careful with it, of course, not just randomly go ahead and run outside anything that was that's in this folder, but. In general, I don't think that's a problem. I don't know if other people are using Docker with and are setting up some user inside. Okay, I'm not sure. I don't. Okay, maybe it's a security issue, but I don't do it. Anyway, so let's remove this ABC because I don't need it. And then now I think the command is zil install. So, oh, I don't have zil here. Oh, and I saw that I have cpan-m. Do I have cpan-m? Yeah, I have cpan-m. So, but I have cpan file. Okay, so let's try to see the README. What does it say? It doesn't say how I need to.
It does at the bottom.
Does it say anything?
It said dzil somewhere.
Zil test author test. Okay, zil test. Okay, yeah, but I need this Zilla for here. Okay, so I need to install this Zilla for this. And I thought I have this Zilla. I'm going to use no test because I don't want to run all the tests. It will take a lot. Okay, forget about it for now. Sorry, I just stopped it. I just stopped it because I have a better idea. Okay, so I'll show you how I built this Docker image that I was using. And I'm going to rebuild it with this Zilla already installed. So I won't have to repeat this again and again, okay, in the next 10 minutes. So let me show that one first. So work my Docker. So it's a brilliant name, my Docker. I have a file here. Let's see the README file of it. Okay, this is the README file, and I'll even show you. This is GitHub subgob my Docker. So it's in a Git repository. Okay, and I'll put it in our file. Okay, so this is where we have our README file, and I'm going to just add this so we will have the access to this repository. Okay, so what we have here is the command how to build this Docker image, and then the alias I have. So I will have this dr command. And I'll explain to you that a little bit. So the way you run Docker basically is that you can say Docker run. Let me check something before that. Docker image as Ubuntu. Okay, so I have Ubuntu 20. 2210. That's good. Okay, so I can run a Docker image like this. Docker run minus it, then and minus rm, then the name of the Docker image that I would like to run, and then the command I would like to run inside the Docker. So what I say here is run a Docker container based on this image. Okay, so it's an Ubuntu image version 22.10 or tag 22.10. Make it interactive, the session. That's the -it. Actually, it's I think two things, but that's just how I use it. And -rm means that once I stop the Docker, once I stop the container, remove it from my disk. Actually, let's try to run it without this. Okay. Then I say what image, and then I say what command to run inside. So now I run it, and it immediately opened a terminal, and now I'm inside this Docker container. Okay. So there is an image.
That command has given us enough information so that we don't need a Docker file to do the configuration. Yeah, this is just a base thing. Yeah. Built on this image and run it immediately and let me join a bash session.
Exactly. I'll keep putting here these things. Okay. So where did this get this image from? Well, it was on my disk now, but if it wasn't, then it would go to this website called hub.docker.com, and it would look for the image here, Ubuntu, and so that's where you can also find various images that you would like to use. And here you can find all kind of tags, let's call it version numbers or version names that you can use. So you can say Ubuntu and then colon. Let me show you again here. So I used Ubuntu colon and the tag. Okay, and this tag, well, in case of Ubuntu, I guess it refers to the actually released version of Ubuntu. But you can have all kind of other tags. You can see that this tag, or so some people use the name of the release. I think that was 2210 was called Kinetic, or some other people like to use the version number of the release. And this specific tag refers, I guess, to the build that was created on that specific day. Okay, so a Docker image is basically I mean, people rebuild their Docker images and republish them here, and especially this Ubuntu image, I guess on a daily basis or whenever there are new patches. So you will add every time you run this Docker run, it will be able to fetch the most recent version of the images from this website. Okay. So when I ran this command, it looked at locally, and because it found the image, it immediately started to run. So let's and then here I can just run ls, and I can do whatever I'd like, but I'm confined to this Docker container that's running. Okay, I didn't map any of my external folders on external directories, so it doesn't have any access to my external system, to my own file system. All of everything you see inside here is inside the file system of that Docker container. So if I quit this one, Control D, I exited, it's basically more or less gone. Okay, why I'm saying more or less? Because I can run Docker ps-a, and I can see here that that I ran this image. The name of it generated the random name for this, and then I exited like that 9 seconds ago. Okay, it started with 3 minutes ago. I took 3 minutes, and then I quit the session. Okay, so basically what you have in Docker is you have images that people can build and upload to this hub, and there are various other places where they can publish their images. And you can also build local images. So there is an image, and then using that image, you can start running what we call a container. And the container is much more temporal. Okay, Okay, so the container is the runtime version of the image. Okay, so usually people, I mean, we could get back to the same image if same container if you really wanted, but usually I would just, in this case, I will just remove it. Okay, so docker rm, and I need to type in the name of the container. Now this name was given totally randomly. Okay, Docker, if you don't provide what the name of your container, then it will generate a random name. So I remove that, and now I can look at it and I say there is no container there. Let me show you something else. Docker run hello. Let's just a second. Docker image ls. So this is the way to list all the images that I already have on my system. So there are a couple of images that I used for work. If I say docker run hello world, you will see that first it says unable to find image hello world. Then there was a quick few seconds where it was downloading the image from this website and then executed whatever is in the image, which is printing out this text. If you look at the Docker image list now, you will find that the hello world is here. If I scroll up, you will see it's not here. So the image wasn't here. When I ran the image, it looked at it locally, it couldn't find it, so it downloaded from this Docker hub, stored the image, then executed the image, and if I run docker ps, sorry, with -a, then here, this is the image, so it is the container. So it was based on this image, and this is the name of the container that was used, and it's here on my disk. It's taking up some space, not a lot, but it's taking up some space. So I don't really want it. I would like to get rid of it, but before I get rid of it, let me run it again. So I run it again. This time it doesn't say it can't find locally. If I scroll up again, you can see that here at the beginning it was unable to find, and then it was pulling the image, and this is the ID of the image. So this happened because the image wasn't on my disk, and this is the actual execution of the image. This time you can only see the execution part because it found the image on my disk. And if I run docker ps -a again, now you can see there are two of them because I ran it again. So I can run docker rm, and then I can remove these images. Sorry, these containers. So I just remove the containers because I don't need them. And what I showed you earlier, tried to show you, is that I can give this --rm flag. And what this will do is that it will execute the container. But once the container is done, it will be removed automatically. So I won't need to remove myself. So now again, it does the same thing, prints out, this is its job. It doesn't need to run for a long time. It just prints out some text. So printed out the text. If I run docker ps -a, there's nothing here, because it automatically removed the container. So if you run let's say, if you'd like to use a Docker image to run some batch job that you run, and then it does some work, but then you don't care about the container anymore, then it's good to use this --rm flag. On the other hand, if you'd like to have a Docker container that you will get back to it later on, then it's better to not remove it, of course. And I hardly do this, so I'll have to look at the slides now. Code Maven slides, Docker. So here are the slides I usually use. Okay, I don't have the command here. I'll find it later. actually, this is the one I wanted. Okay, so let's see this one. So now I'll so far it's okay, right? Or any questions?
Well, yeah, just a one. So if you've terminated the container and it's not been removed, does that mean you can still access? You can't restart it and continue that instance of that container, can you? That's dead. But
that's what I wanted to show exactly, how to restart.
I was going to say, or can you access the file system that was on it? Any of those kind of things would be useful because, yeah.
So I don't know if I'm quite sure you can access the file system as well. But I know how to. I can show you how to rerun it. Okay, so exactly that's what I wanted to. I just didn't remember exactly. So let's start again with this. Where was this? The Docker run -it without -rm and then Ubuntu and 2210. And I'm using this because I just don't want to download a new one. Okay, and I'm telling you, do it in interactive mode. And something I forgot, Docker run. What? Sorry. Okay, typo. So now I'm inside this container. This container doesn't have any file system mapping. And I am here in the root directory. So let's say echo. Gabor was here. ABC. Okay, good. So I have here now. I have here now a file called ABC. And I guess I can run cat on it, and Gabor was here. Good. So I quit this container. Okay, Control D, I exited the container. Docker PS A minus A will show me that this is the container. Now I forgot to give it a name, so it gave me this random name. But now I can get back with this command: Docker container start and the name of the container. Docker container start. I think I need to give -it bold lammer. Just -i. Yeah, okay. So I'm back to the container ls-l, and the ABC is there. Okay, so this is the same file system. If I installed anything on this container, okay, so now let's say apt. Let's check this one. Perl -3 version. Okay, so we have Perl here. Less, I think less. You don't have less. Okay, so apt get update. Okay. And then apt get. What is install less? This is how it's called. Yes. Okay. So it's now installing. So now I have the less command. Okay. Wonderful. Less ABC. Okay. Now I quit the container. I run it again. And it's still there, installed, the command. So this container is, and all its file system is stored on my disk somewhere. Okay. Let me see if I have here a page. Here, okay. So here, a copy file from the stopped container. So this is exactly what you asked for. Okay. So you can do this Docker container CP, the name of the container, and the file, and dot is the external name of the file. So if I'm here now, let's move outside. So now outside, I don't have anything. I can Docker container CP ABC, and I copy it here. So now I'll have a file ABC here. Okay, so I copied from the stopped container a file. And the same way I could copy back to the container a file if I wanted. Okay, so that's here. Now what I actually have here is Ubu, which I ran this way. So okay, so to make it easier, instead of finding the random name, you can say docker run -it. Okay, so it's going to be interactive, and then you can give a name to your container. So let me run this. Show you. Docker docker run. Okay, whatever. -it -name Ubu, and then Ubuntu 2210 and bash. Okay, so I quit, and if I run docker ps -a, then you can see that there is now a container called Ubu. Okay, it's probably easier to pick the name yourself, and then you can reuse it, than to rely on finding the name yourself is this really strange random names. One more thing, actually, I'm just getting back to this container, and here in this other window, I run docker ps. So docker ps will show the running containers, and -a will show all the containers, both the running ones and the ones that are stopped. Okay, so that's why we had to give the -a, and then you can see that this is exited or excited or whatever it's called in English. Okay, it's very excited.
So the control C or the control D you did to get out of the container, I was assuming that did a hard terminate and would leave the container in a state that was not recoverable, but this clearly isn't. No, it clearly isn't the case. But if you left the process, if something was running and you did a control D, it's not going to carry on from where it left off, is it? You're going to have to start that process again. Let's say you were running a top command or whatever you were doing, or running a web service or something. It would not be running if you refired up the container, would it? You'd have to start again. Is that right?
I think no. So
we've got to test it.
If you're running a web application and you exit, so Control D is basically just same thing as typing in exit. It's not Control C, it's Control D. So it's just typing. It's just the same thing as you would do as typing in exit. So it's just shorter. But no. So if you have a web server, a web service running, and that's usually what you have there. I mean, if you have top and you press Control D, then nothing will happen, I guess, because then it would go to top and not to your terminal. Yeah. So whatever top understands from the Control D, that would happen. But if you have a process basically in the background, okay, and you still access the container through its bash, then when you stop it, it will, and then you start again, then the web service is back up running. Unless, I guess so. We'll see.
I'm wondering, because as soon as the bash, if there was a long running process, then I get it. If you weren't running bash, I think my question comes from when I've used Docker before, I've never launched it to be interactive. I've always launched it to say, build these resources and then run this set of processes. And then when the container ends, it's ended and that's the end of it. We've got this kind of interactive one now. And if you're exiting out of an interactive session, I'm wondering if the container almost carries on or whether it stops because the bash command has come to an end and you've exited that. Yeah, I guess just experiment is required.
So the thing is that I'm wondering what really happens there, because the way I use it, for example, is and we haven't got to there. I'm using Docker Compose. That's one of the ways to orchestrate several Docker containers. And then I have, let's say, one of them is a database server. So I have several containers running. One of them is a database server, and the other one is, let's say, my web application. And I just tell it to start it and stop again. So I didn't think of how it would really affect, but yeah, we can try that. Other question that maybe something that I can answer? To look better in the video, yeah.
We can edit that bit out.
So anyway, so this is basically one way to use Docker, that you start a Docker container and then you can do whatever you like here. Now, of course, let me remove these containers now. Docker, remove ubu and bold, whatever it's called. So one of the things that I would want to do is interact with my own file system, right? So I can do this by giving it -v. Actually, I think this is an old the old way to give it. So, but I'm going to show you, but I don't know the new one. And so, and here you need to give the path to the external folder and how you would like to map it internally. So externally, I would say, okay, pick up wherever you are, so the current working directory, and map it, let's say, to opt internally. So now I run this, okay? And if I run ls-l/opt, so I would like to see what's in the opt directory, and these are the files that I also have on my file system. So it's now the work my Docker folder. Let me open another terminal in the same here. So this is outside. Okay, now I'm in my own computer, my own prompt. These are the files, and this one is inside the container. And the same folder was mapped to the /opt internally. Okay. So now I can do whatever I'd like to do and play with this.
So if you did a cd ... there, it would presumably take you, what would it do? Just tell me.
Well, I am now here inside, I am on the root of the internal file system. So if I go to /opt, then I am in the /opt internally. If I do cd ... then I'm back to the root of the internal file system. It can't get out of the file, but it can't get out from the folder that I mapped. It can't go further up in your file system, closer to the root. Okay. Of course, I could have mapped. Okay, so let's map. But if I give the same name, Docker remove ubu. Let's remove it now. Let's have an auto remove now, and I could map here /etc. Okay, probably not a good idea to start playing then, all right, because now I'm mapping my own etc. I can do this, and then now if I start ls-l and opt, this is the file system. Oh, I have a broken symbolic link. Okay, so this is the etc in my own file system. Okay, maybe it wasn't a good idea to do this in a video.
It might be that I wondered about that, if you had a link to something outside in your.
Oh, all right, yeah, you're right. So because it's an externally a mapping and internally doesn't exist that folder, probably that's the reason it looks broken.
Yeah.
So well, yeah, okay. So
maybe just stops symbolic links from working altogether.
Yeah, well, if you map it to a different place, because this would try to access the /etc of the image of the container. Sorry.
True.
Okay, which in the container probably doesn't have this VTRGB whatever it is.
Yeah.
Okay, but if I
Makes
go
sense.
on my own file system and then I see etc VTRBG, then it's a correct link. Okay, because this etc is on my file system, that's fine, in my own file system.
Yeah,
but
yeah,
here this was going to the file etc of the container, and that one doesn't have this specific whatever it is because I haven't installed it. Okay, so it's a good point. I didn't think about that. So it's not that bad. Anyway,
so that would override, not overwrite, but override the container's own contents of /OPT, for example. If it had its own contents of OPT, you would see your whatever you'd map to it instead of the container's own version. Yeah.
Exactly. So probably you want to pick some folder that doesn't exist, or that you hope that doesn't exist. Or, yeah.
So if you create one that doesn't exist, presumably, well, if you use a folder that doesn't exist, it will create it. So you said /op, but you could say /fred or something there.
I think it'll create it as such. You'll just see it as that, won't you? Yeah.
Okay, let's see this one. Okay.
Yeah.
So internally, I don't have this cuckoo. But now I have, and it is mapped to my current working directory outside. Okay, and you can give several of these pairs, so you can map a couple of folders in various places. Okay, so you can give it another -w and do whatever you like. Okay, so this is the way to enter. So one of the ways I use it is that I launch the Docker. I run the application inside the Docker container, but I use the editor outside. I mean, it doesn't really matter for me because I'm using Vim, and I can run Vim also inside the container. But if you use a different UI-based editor, then it's probably much more convenient to run it on your own computer. Okay, on the host computer, and of course you also don't have to install any of these things inside the container, because the container theoretically should only have whatever you really need to run this program. Of course, whatever you need to develop. So maybe you do have the test libraries installed there because you want to run the tests, even though you don't need those on the runtime of this system.
So you wouldn't really need Git and everything installed on the.
No, I don't have Git in the container.
Yeah, so that could all be done.
You don't need.
Yeah.
Okay. So what kind of so here we just use the plain Ubuntu image, but if you go to this website, the hub, you can have all kind of images. Let's say Postgres. Okay, so you can have an image that already has Postgres database installed and running. You might need to configure it because you need a password and whatever, but it's basically you can run it, and it has all kind of versions of Postgres, and then you can ask, okay, but what kind of this Linux distribution it's using, and you can pick the distribution. So Bullseye and where is the other one? And Alpine, I guess. No, so Bullseye is one of the Debian distributions. Okay, and Alpine, I think it's something else. It's nothing to do with Debian.
It's a cut down minimalist Linux.
Yeah. So it is, and you can all kind of architectures you can pick and whatever. Okay, so there's quite a lot of interesting things that you can pick. Let's say if you would like to run Docker, if you would like to use Perl, then of course the Ubuntu image comes with Perl, but you can have an image here which is either Buster or Bullseye based. Okay, so Buster and Bullseye is two versions of Debian, and you can have a threaded version. So different ways of Perl being compiled, and different versions of Perl. So I mean, these are the tags. Probably they represent the same version of Perl. I mean, if you trust the vendor of this, okay, because the person who generates this, or the organization who creates these images, can put any tag on any image. Okay, so I could put in 5.73, and whatever I put there, it doesn't have to correspond to it. But usually, I mean, I can assume that if it's called 536, then it's probably Perl 536 inside. Okay, so you can pick, you can be a lot more specific of what you would like, or you can just say, okay, just give me 536, 530, just gonna give me 5, okay? It will give you most likely the most recent Perl from 5 up. If you say 536, then whatever is the most recent 536, which is right now apparently 0, but if there is going to be a 536.1, then giving 536 will automatically upgrade. Giving the 536.0 will keep you on that version. So that's the trade-off. You have to decide whether you would like to be very specific in what version, which image you use, and then you have to keep updating it. But it's probably better this approach than using. There is the latest always. Many of these projects has a label called latest, and it will just give you the latest Docker image of that series. So we say Perl : latest, and that will just give you the latest Perl, the latest Docker they have. Okay. And then this is official. Okay, and then you can have because you see that there are all kind of other things. So there's all kind of people uploaded. There's a Perl tester, there's Perl on CentOS, Perl critic. Okay, so I guess this is an image that already has Perl critic also installed. Okay, so questions here? So where are my slides? Here. Okay. So here is the stop instance. These are the things that, okay. So one way, okay, so what you do is you start a container, let's say an Ubuntu-based container. You install all kind of things in it because you need them. Let's say install cPanel, you install all kind of modules, and then you stop that container and you know how to run it again. But at one point you would like to create an image from it, either in order to distribute to other people, or because you would like to run 2 containers, but with the same installation already. Mm-hmm. So there are 2 major ways to create an image. One is the bad way that I'm showing you now. Okay, and I'm going to show you then the good way. So the bad way is that you played with all this installation, you installed whatever you needed. So now you have a container, and you stop it, and then you say Docker container commit, the name of the container and the name of the image, which would look like this. So name of the image and the tag. Okay, and this will create an image locally on your disk based on the container that you created. Okay, so you had this container, installed all kind of stuff, and now you create an image from this. So this is sort of the easy way, but it's quite wrong in my opinion, because you don't really remember what you put inside, right? You experimented. Okay, oh, do I need this package? No, this didn't help. Okay, let's try to install that package. Okay, and then you got something working, but you don't know what's inside. But this can be done. Okay, the other way to do this is okay. This is just the whole thing. Okay. Okay, these are just placeholders images. So the other way to do this is to create a Docker file where you describe exactly what you would like to install, and then you run Docker build, and it will create the image based on that file, on the description. So it's like a few commands of how to create a Docker image. That's a little bit harder because you have to actually think about it and decide what you put in there. but it's the more correct way, because now you can put this file in version control, and then you can see how you created it, okay? And you can repeat that creation. So this is quick explanation about the Docker file. So Docker file is actually called Docker file. So it's not just some random name. This is how it's called, with a capital D, Docker file, okay? Like you can see here. You can give it a different name, but this is the default name. And then inside the Docker file, we'll see more information. But the first thing you have to put in is what is the base image. So you will have to install, we'll have to base our image on some other image that's on Docker Hub. Okay, so here I said, okay, let's base our image on Ubuntu 20.04. I guess I created these slides or updated these slides 2 years ago, 2 years ago. Okay, because that was 23 years ago. Okay, so I have this file, Docker file, and then I can say Docker build -t and name of the image that I'm creating, and dot, because this is where the Docker file is in my current folder. Okay, so let's see. Shall we see this? What happens? Yeah, we can see this. Work, slides, Docker, and this is in examples from. Examples from. So I need to run Docker build. Okay, what do I have here? I have this Docker file. This is the only thing I have here. And this is what I have in this Docker file, Ubuntu 20. Let me update it, okay? So it won't, let's do 2010 now. Okay, that's the most recent one. Okay, so now I run Docker build -t, giving a name. I will give some other name. Kukuriku, I like Kukuriku. Okay, and I say dot. Okay, this says that look for the Docker file here. And if you will need other files, these are related to this current folder. So I run this, and it quite easily created the image because, well, it only needed that image, and I didn't tell it anything to put in. So now if I run Docker image ls, then there is an image called Kukuriku. It has a tag called latest because I didn't say what is the tag. So after the colon, I could say a tag. I didn't say, so by default, it gave me latest. You could actually see that the ID is the same as of the other image, because basically it's the same image. It didn't need to do anything, right? It didn't tell you to install anything. It's just the same image. So that's not really useful what I did, but it's a good starting point. And now you can run it with the command. And I didn't want to use my Docker because I think I have this. I already have that image, and I didn't want to ruin that one. So now I can, because I created the image called Kukuriku, I can say Docker run -it Kukuriku bash, and I'm inside. Okay. So I created my own image, my own Docker image. Okay. So let's go on. This one, the CMD, what I put in the Docker file, you can have only one of them, one of these CMDs, and this should be the last thing you put in the Docker file. And this is what will be executed when you run Docker. So if you're wondering how this hello world worked, you remember I ran Docker hello world. Basically, this is the whole thing. Okay, this says from some image, and then echo and that text. So this will be executed when someone runs the Docker container, unless the person overrides it with the command at the end. Okay, but we would like to install some stuff on that image before we create the image. So what you can do is, after you have the from, you can say run this run will be executed during the Docker build phase. So maybe the name is not really good, but this command will be executed while you run Docker build, when you build the image, not when you run the container. So here we say just apt-get update, apt-get install htop, and then we also created a file here, just so you see that whatever file you create in this phase will be in the image. So whenever you run a container based on that image, that file is going to be already there. Questions? Need time to digest this, or it's all fine?
I'm fine with this bit. You're much more onto the part of Docker I've used before now. So the first bit was very interesting and new to me, the interactive bit. Now this is the bit I've done before, so I'm good.
Okay.
I might top up my cup of tea in a minute.
Yeah, my tea is just gone, but my teapot takes like 20 minutes, so I can't expect to make one. I'll just finish a couple of things. So let's say you would like, instead of creating a file like this to be in the image, that's not really what you usually do. What we usually do is that we create the file outside in our file system, and you'd like to copy it inside. So you can say, okay, so just copy whatever welcome.txt you have in your own folder inside. And this is how you call it inside. And because I put dot, it will just put it wherever it is now in the file, in the image. So that's how you add files to this image. And nothing interesting here. Endpoint is another way. So CMD and endpoint are sort of similar. They have some differences. Both are telling what to run when you run the Docker image. And here is the difference. So, oh, I forgot. I keep forgetting this. One of them, so you saw that I put bash at the end of my command, Docker run command. This told what program to execute. So that thing would, as I recall, replace the entry point. It will either replace one of them. Okay, one of them is fixed. The CMD, I think, is fixed, and the entry point can be replaced.
I have no real idea what's going on at this point.
Okay. Sorry, I misled you. Let's just try look at this example. Curl runner. Okay, so here we are, and I build this image. Right. Docker build -d kukuriku. It will override that other image I created, and dot. So what it does now, oh, sorry. Let's edit this one as well. I don't want it to pull the old version of Ubuntu because it just takes time. And anyway, why not update it? Okay, so it's faster because now it already had the image. So now it does exactly the commands, what I told it. Based on this image, get apt-get update, and then install curl. So far, it's good. And these are the commands. So what entry point says that this is the command. Okay. Together, entry point and CMD is the command that will be executed when I run Docker without any parameter. So basically, it will run curl, and I don't know why I put it in this way. Maybe I don't know. So it will run curl and will give this flag and this URL as a parameter to curl. So basically, it will run curl -- silent this URL. Let me show you. Okay,
Yeah,
so the image.
That's nice and intuitive, being upside down.
Yes, I don't know why I put it in that order. Not a good idea. So, but maybe there was a reason. So,
Yeah,
okay, so I created this image. Now I can Docker run Cuckoo, and I say ---- rm because I don't want the container to stay around. Okay, so now it executes that curl command. Okay, fetching this URL. Okay.
And then the container's stopped. It's finished. It's done what you said, and then the container's ended. Yeah.
Yes, and it was removed because of the ---- rm flag.
Yeah. So,
I could tell it to do something here. Let's say bash, as I tried earlier. What it now tries to do is run curl bash.
mm-hmm.
So the better way would be to show is that, let me check, HTTP get. So this is what we get in the browser. This is basically just I don't know if are familiar with HTTP bin. Let's do this SSH. It just gives you all kind of all kind of endpoints that you can play with, so you can play with your web client, HTTP client. So there is one. This one, headers. Okay, so let's say this one. I go to this. If I access this URL, it will tell me what were the headers sent by my browser. Yeah, you see, this was the user agent. It didn't send much. Okay, so I can run this. Okay, forgot to give the name of the container, Cuckoo. Okay, so now I executed curl with this URL, and this is what it returned. It's slightly different from here, right? Because here it gave origin and URL and whatever.
Oh, so, did it replace the options in the command, or I forgot?
So right now, what? Where is my slide? Right now, the only thing that is fixed is the curl command. The -silent and okay. these are the ones that I just replaced.
Okay.
So that's why I had here this whatever, what is it called? Progress bar. Okay. If I give it silent, it's very silent, then it will run the same thing but in silent mode without the progress bar. Okay. And let me just to make sure, let me switch around and Docker build. Okay, so rebuild it. Now let me, before I show you what the same thing again, let me look at this. So it says using cache. It says using cache. When I built it earlier, if you recall, it did a lot of work installing all this stuff. Now it recognized that up to this point, nothing has changed. And whatever it built up to that point, it was using a cached version of that image. So only this last part had to be changed in my image. And this was removing intermediate container and adding a new one. This was happening. So the way Docker works is that it has these layers, and it creates, each run command creates a new layer, which on one hand costs us some disk space. On the other hand, especially when we are building or trying to figure out what to put in our container, it's useful because we don't have to rebuild the whole image again and again, because it's caching the first part already. So we can just add more and more stuff till the point that, okay, we are satisfied with the whatever, and then we can put together these run commands.
Yeah, very important when you're installing Perl modules like Moose and things that are enormous, because they take minutes to do it, and you could be there for all day.
Right. Okay. And that's how we started here.
Yeah.
I didn't want to do that again and again, so I said, okay,
Yeah.
let's build it properly, and we're still stuck with it. Okay. So, but we'll have a break now, and then let me just try this now. Docker run Kukuriku headers. Okay, so you can see that this is working. Okay, and if I run it without anything, then it does the default. So the slide will be updated when I commit these changes that I just made. Git status. Okay, so let's git add the Docker file. And there was another one, git add from.
Can't help thinking those last two entries, so entry point and command, are very badly named, because one is the command we're going to run and one is the parameters of the command we're going to run.
Yeah.
Yeah, I even put here something Docker.
And the order not being important is also insane to me as well. Yeah. I mean, it makes sense now we've explained it, but you'd be sitting there all day trying to work out what was going on there.
Let me just make sure. Okay, so these comments are okay. So now we'll have this git add. Okay, so let's have a break now, 10 minutes. I'll push it out, and then the slides will be updated. Actually, I have to run, and do I have to run? I don't remember anymore. I had to reconfigure something there. And this used to be automatically updating the slides, but I think I stopped that for some reason. Anyway, in 10 minutes we'll continue. Okay.
Okay.
Okay. Thanks.
Bye-bye.
Bye.